Welcome back to the stream. Welcome back to the stream with the microphone actually turned on. We're gonna do some more computering. This is a kind of weird granular synthesis project that I have been putting together on a whim. It's written in C++ and a little bit of Python using the juice framework. Oh, is that Tuco? Gosh, Tuco is pretty good at noticing when I'm getting this started. Tuco's fountain over there is really loud. He's also purring quite a bit, though. Oh, let's see if I could close the door and maybe have less of the fountain noise in here. Tuco and I should switch chairs. The one he's on is quiet, and the one I'm on is comfortable. Oh, let's switch chairs. Do you want that chair? As of now, it's just an offering, and he's got 2 chairs. Okay. That noise. Oh, I think the chair is rattling against the or the camera tripod very slightly. Oh, I've got 1.7 gigs of Bob Ross. Oh, you want out? Yeah, you want that?
The leaker's free.
Oh, hey, Tuco.
Small display. Philistines beware. The leaker's free.
Marquis. Sortie awesome. Lateraling site. Devising under rhyming toners, solutions, multifaceted, itchy propulse, plumping repaint, sortie awesome. Gussied owner. Frogging's look. Irresistible. Idiosyncratist. Medallion and consort design arcane gift underused and sees reps. Sees reps. Sees rep. 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 Sees reps. Sees reps. Sees reps. Species reps. Species reps fever. Species reps fever. Species reps fever. Species reps fever.
We have to take care of this.
We're going to go to our look a little bit loose. Come around your bed.
Sap green. Sap green.
And the medium is Damar varnish, linseed oil, and turpentine.
And just a little bit of
Shading. And then we're going to take our liner and thin that paint.
Just
Bring it to that edge.
Take care of this.
Juice on one flat side of the brush.
dry 2-inch brush, or you could use a 1-inch brush. All black. Yellow ochre. So we have blue, black, a little yellow ochre.
Maybe we'll put highlights or leaves on here. Just use highlights or leaves on here.
I'm going to add a little Van Dyke brown to it, maybe a little black. Juice, something that will help you when you do your next one.
hair hanging down by his face and ear.
Have a black light thing up with
Into medium.
Come right up
Picking up that.
and then your
Need a button for that.
And light.
Wine.
Or move.
Sometimes the mod wheel lags really badly.
I would never.
Hitting one of the bugs on to fix. Yeah. It's easy to just completely flood the queue. So I did do the thing that I said that I would do between streams, and I added a listener interface for the, actually not just for the synthesizer voice, but also for the grain index. So the grain index can report which grains are being accessed, which ones are being loaded. So that's what all the colored rectangles are coming from. Well, not all of them. That's where the red ones for loading grains are coming from, and the green ones for cache hits are coming from. The yellow rectangles are grains that are currently playing, which I'm actually getting from the synthesizer. And I have that set up ready to give me a bunch of additional information about the grains that are currently playing for the waveform display, which is one of the next things to implement. So yeah, the voice has this grain voice playing callback you can register for, which gets called in the audio thread pretty frequently. So it's somewhere to look for performance bottlenecks, but the idea is that it takes a lightweight lock or uses a hardware atomic data structure, something that is relatively quick to just store some data in and then get back to audio processing. And there's a similar doodad over here in the data store. Yeah, so we've got these callbacks that you can get for grains that are stored, visited, or missing according to the cache. So then, from the UI's perspective, I actually want to aggregate all this stuff into frames, and the notion of what a frame is actually per component, at least the way it's usually done in Juice. This is something that is often like a rough edge in UI frameworks. You have this kind of localized way of writing UI components, but then you have, in the end of the day, a stream of frames that your app is producing along with everything else in the system. And even if you have a monitor that's running at a free refresh rate, then ultimately your application is cooperating with a bunch of other things on the system if it's not full screen, and you have to decide where those frames go in this stream of updates. So someone's got to take all the different repaint requests and consolidate them into frames of video, and it's a little frustrating that that's happening in multiple places in Juice instead of like once per application. But even if that weren't the case, like it is a general problem in like windowed UIs that you can have a lot of different things animating on their own clocks, and someone's got to collect those into frames. Anyway, since that is per widget, like per editor here in this case, instead of per application, it kind of makes sense for the editor itself to be the one that's consolidating the data into those frame-wide units. So in this case, we get all these callbacks and we store grains in a set, and then we can swap out those sets at the boundaries between our frames. So I ended up putting that logic in this live overlay, which is part of the map panel. Yeah, so Juice has this sorted set container, which is just like a set, like a map that has no values, just keys, but it's intended only for primitive data types. Like it doesn't handle arbitrary hashable keys. So I don't know. It's just one of the different data types we could use for this. The idea is I want to be holding this mutex, which I share with the real-time audio thread, for as little time as possible. So I just come in and swap these sets with some that I have here on the stack, and then I can figure out which ones are actually loading and convert the sets here into rectangles. And this is something else I still need to work on. This grain rectangle calculation is not quite right, so I think some of the rectangles are off by one. One of the ways I wanted to debug that, though, was just to be able to click on the grains and be able to play them, because that seems like it would be a good thing to do anyway. So I might just do that, but that requires adding a little bit of infrastructure. That might be a good thing to do next. Make the grains clickable. Anyway, the thing that I was just debugging before streaming this, I needed to figure out how to deal with grains in the sequence that are not loaded yet. Since in general, this project is a compromise between like real time and the realities of a large data set that you're streaming in. So when you press a key on the MIDI keyboard, it has an opportunity to delay that key just a little bit while it fetches the data that it needs, which it does. But then after that point, if any of the grains that it is trying to choose aren't actually in the cache yet, we can't really delay, because this, at least the way the synthesizer is written right now, you can't have variable timestamps on all the grains. The grains are always at a fixed rate, which is probably what I want anyway, just from a results perspective, but it's also a little bit nicer to implement. So each voice, once it's started, either produces an unbroken stream of grains or it glitches, which is currently what happens if it just absolutely can't find anything to play. So it tries to avoid glitching by using a reservoir of grains that voice has previously played. So the idea is I don't want to just grab random grains that aren't even applicable, but if there's something we were just playing, then maybe it makes more sense to play that one again instead of just glitching out. So that logic tries to keep a just like well, it calls it a reservoir of unique grains. So, and we might be playing one grain multiple times, so it does need to deduplicate them. So it has a set of grain numbers and then a vector with all the rest of the information. I guess the next problem to solve with this queuing issue is if we are lagging behind, like what do I actually want the failure mode to be? The failure mode that I had kind of by accident before I even really started to look at this code was that the synthesizer would just kind of skip grains that were too far behind. Well, I mean, before I did anything, it would just end up I mean, if I didn't do anything at all, it would hit a null pointer, right? But the easiest thing to do was to just stall processing this voice's render queue when there are no grains available. And so that, you know, if everything is cached, it plays correctly. If everything is not cached, then you end up with these sections that just repeat one buffer's worth of audio. So it sounds super glitchy and broken. Then I tried just doing a very basic version of this reservoir that kept a limited size list of grains that we've played recently, and then randomly replaced and randomly chose grains from that list. I think we might have been doing that on the last stream. already. And that sounded okay-ish, like it sounded not broken for the most part. It had the issue of being very slow to respond to changes in the grain sequence while the voice was playing, because stuff would just kind of get stuck in the reservoir indefinitely. So it's fine if you're just playing notes and not changing anything, but if you're trying to modify notes after they start by using the pitch bend or mod wheel on the keyboard, then you end up kind of fighting with the reservoir, because you end up with some new grains from that use the latest settings, but then you're also kind of randomly picking a bunch of stuff that is arbitrarily out of date. And looking closer at that, it turns out that it is actually loading, it is actually filling up a queue with tons of grains, because when you request one from the storage layer and then give up on it, the storage layer still actually loads it. So the this grain data layer has a background thread pool that generates all these things, and that just has a queue that we'll want to fill up. So I'm just moving my queue backlog. Previously, I would backlog the queue in the background worker threads, but the synthesizer would be fine. Now both the synthesizer and the background worker threads are backed up. So, I could put some arbitrary limits on these queue sizes. I think what I actually want to do is limit how many, limit my total backlog size, right? This could be as simple as some kind of relatively global flow control mechanism where I can ask the index if it's backlogged, and if it's backlogged, then I stop trying to retry grains. That would probably take care of this. So where do I need to know this? I need to know this during audio rendering. I think I've got easy access to the index here. I haven't decided if I'm going to put this code anywhere. So far, I've just been keeping it on a private repo. I don't know if it's the kind of thing I want to actually publish or the kind of thing I just want to use to make noise. I've also been flirting with the idea of canceling loading jobs, but that's, in general, making cancelable asynchronous APIs is something you want to avoid just because it gets really complex and it's often not worth it. I can sort of get some of the benefits of having a prioritized queue if I'm, deprioritizing the relatively unnecessary grains when things are backlogged. I guess the way I split up these jobs, the index itself is in charge of the cache. So where we store the waveforms once they're loaded, but it's not actually in charge of the loading process itself because it doesn't have access to the thread pool. That's all done by this outer, I was going to say outermost, but it's more like an outer more object, grain data. This is what actually has the thread pool. Wow, and grain voice has its own reference to grain data, doesn't it? Because it needs that for grabbing the actual waveforms. That's good. So I can just ask grain data for, like, that would be a sensible place to put, like, information about how overloaded the system is. The Tuco's fountain gets noisier and noisier when it gets emptier. It kind of reminds me to refill it. I'm kind of tempted to just have an atomic int that keeps track of the number of outstanding loading jobs on all threads. Alright, that could just be like a load average. I kind of would want to put that in the UI, right? I haven't really settled on where I want to put like fast moving text in this UI, if anywhere. Currently I've got stationary text and animated charts. I've been reluctant to put text on the charts, even though they might benefit from it. There's a question about why some people write functions in the header files. There's often a good reason for it. Like in C and C++, it's like often you're choosing where to put code for practical reasons rather than aesthetic reasons. And it can make a big difference what compilation unit your code is in. So like here, I have some stuff that's in the headers and some stuff that isn't in the headers, and that's usually intentional. The stuff that's in the headers is either stuff that I want inlined or stuff that I want, stuff that I want the compiler to have the opportunity to inline in certain cases, or it's stuff that relies on template parameters. But generally, like, the first decision is, like, does the compiler need to know this information only when you're compiling one module or when you're compiling anything that interfaces with that module? And sometimes that's a like API design issue, and sometimes that's a efficiency issue. Like sometimes I'll put these small data types pretty much entirely inline because I want them to basically just disappear in optimized code. Like I don't want to actually be generating code that calls the constructor and then moves some values around and then returns. Like I just want the compiler to know about this data type and for it to put the right values in the right memory addresses as early as possible. And it can't, like the compiler can't do any of those extremely easy optimizations if the code is in a different file usually. Oh, there's a question about Tuco. Tuco's doing great. Yeah, you might notice he's a lot more round than he was earlier this year. He's been eating much better, and he had big dental surgery in December, and he's been eating much more since then, and he's generally been a happy little guy. Oh, where was I? Basically nowhere. Where would I put that in the UI? Alright, but this text stuff, I could put it up here maybe. Oh, you know, I guess I could have a little... So right now this is a vertical box with a file component and then one label. I could split it into another horizontal box and have this label and then a second label that's just like some runtime status over here. And then I could have that, I could have like a little thing that's animated, which I feel better about than another giant thing that's animated, because I don't want to have to redraw the entire screen at like 60 frames per second all the time, unconditionally. You know, sometimes we'll want to animate, but it would be nice if we didn't always have to. See, it's very easy to just queue up a bunch of stuff that takes forever to load. At least we can exit the app while stuff is still loading. That's a good sign. We do actually have a way to cancel. Well, it's not canceling items, but we have a way to ask the entire worker thread to bail out at the end. So that's what that's doing. Okay, so I guess my plan now is I'm going to add a load average calculation, both internally and for the UI, and for limiting the number of retried load jobs when the loader is already busy. I guess it would make sense for it to be like a graphical display, right? Doesn't Juice have something cool for that? I noticed some kind of like load average measuring stuff in here. I was curious if they had UI for that specifically. I'm sure they have something that would display like a continuously variable value though. Isn't there like a document that just has pictures of all the UI controls? That would actually be handy. They just keep redirecting you back to the Doxygen generated docs. Let's just look at what is a component subclass. Audio visualizer component. It's cute. I want one of those. Bubble. Huh. Like a tooltip or something. Burger. Carrot. Is the thing I want a read-only slider? I might just want something custom, actually. I'm also wondering whether this is actually like a time averaged load average or whether it's an instantaneous load. I was thinking about instantaneous load, but actually like a slightly time averaged one would be useful in both the UI case and for this internal use case. Someone's wondering if the ActiveX is undead here in the juice documentation. Quite possibly. Yeah, juice has been around for a while. I don't think the ActiveX stuff is something they would have added super recently, but there's an interesting mix of older and newer bits of stuff in here. Does somebody just have a list of these UI widgets? Oh, widgets demo. We should just try that. Sure. Let me check on Tuco. Just getting into stuff like food. Hey boy. Squeaky. How do you tutorial? Oh, it's under new project. Hey, Tuco. Where did this go? I actually need to save that somewhere else. Oh, I can hear Tuco purring over here. I want to save this one file. Oh, save project. Ah, okay, that's what I was missing. There's a question about the cat's name. The cat's name is Tuco. Mike is my name. But I could see us switching places. That would be funny. I could climb on stuff and sleep more than I currently do. Initializing that. How am I getting that back? Normally it would be weird to put any of the completion status back here in the kind of singleton grain data object because everything would be per index. But here we are actually interested in keeping track of like global load. I think in this case it makes sense for the individual threads to have a reference to that job's pending. I'm just not quite sure how to divide the responsibilities so it's not spaghetti. It also occurs to me that this really just shouldn't be global, it should be per thread. I mean, it could be global, but I've been trying to keep all the queuing per thread just to keep the contention low. And I think that also makes the design cleaner in general. So maybe we don't do that. Maybe we are actually just looking at the queue depth on the individual threads. All right, do I want to make this something that can have very little effect on the loader during normal operation, or do I might want to make something that is itself really efficient? And I think really it's a balance of those. This needs to be something that I can do during audio rendering. It needs to be something that I can quickly notice whether the loader is over busy or not. Yeah, just thinking about like where the code physically lives, we've already come across a few different permutations of that. And like in this file, I have a class that's defined entirely in the .cpp file, and then I have all the code inline in the members. And that's because this class doesn't need to be visible anywhere else. It's only just mentioned here in the header, so that we know, if that's a name, that is a class, but we don't actually have a complete definition for it in any other module. I don't know if there's any significant benefit to having like a separate atomic counter versus taking this work mutex just to check the Q depth. Like, if we're doing this right, the work mutex should be really low contention, but I have not verified that. Alright, but this could just be a get load Q depth. I don't know if I'm going to put get in either of these. That's kind of redundant. That's a starting point. Could be better, but have some kind of average load Q depth. All right, I was waiting for this to build and totally forgot about it. Widgets. It's like stars in the background. bubble. It does actually kind of seem like a read-only slider. It would do what I want. Can I do that? I guess that's one of the default-ish configurations, linear bar. Oops. Honestly, it might be more useful just to have a text label that updates relatively infrequently. I just start with that. Geometrically, it kind of goes inside the data panel, but I'm wondering if I want to split this out somehow. I think this can be like a self-contained component inside data panel. All right, like I think the update mechanisms here are fairly different. Everything else in data panel is really updating when the index changes using listeners. Whereas I just want this little status thing to update on a timer like every half second or something. Man, Tuco's fountain's making so much noise. I'm gonna refill that and also refill my coffee. I'll be right back. Give you the full screen cap for a minute. Oh, that fountain is so quiet when it's totally full. Oops. What is the default? Oh.
and monitoring the pole gun run is hermetically resting flowers, spelling poly incisively, monitors and branches on the entire 10 decimals.
You ever just suddenly feel really bad? I was thinking about making this parameter configurable, but I'm tempted to hard code it to like 1. So it seems like we only want to do this when there are actually idle worker threads. I don't want to check that per grain, I just want to check that once. I'm more worried about lock contention than this little temporary array.
All videotape introduce singularity, varying gallet, handing station, center, rifle.
Oh, actually, maybe this is basically correct. So I have the parameters set to produce this giant spray of grains, which I am actually getting in the queue, but it's not building up infinitely like it was before. So if I hold down the key, then we'll get that initial spray of grains in the queue as it tries to prime the queue, and then immediately falls behind. I guess we can still get a bunch of separate voices. I don't know if I'm going to call that a bug, though, or if that's just kind of a terrible parameter set for this.
Eruption. Furnished. Rising spawn. Him and son. Reached money's facial. Holster bring. Dismissed to me. Raleigh's. Streams. Not. Man. No. Banana.
Okay. So it didn't completely crash when I had the parameters set to ridiculous values. It just got really, really slow for a while and then recovered. And with more reasonable parameter values, it actually seems to be doing the right thing. Yeah, this is doing what I want now. Still can be kind of laggy at responding to the mod wheel. Some of that's okay though, like the synthesizer sort of takes the parameters when the note on happens as an important requirement, but parameter changes while the note is going are more of a hint, which could be what I want if I'm trying to, you know, fundamentally build a synthesizer that's in over its head with regard to data bandwidth. Those are just gradually getting replaced as the new grains load. And if I release the pitch wheel, it goes back to the cached grains pretty quickly. Right, and if I wanted to clear it up, I can just give it another note on. That's actually kind of nice. Oh, the behavior is kind of interesting when you push the note really briefly. I should explain these colors in the UI at some point, but basically a red is a note that, or a grain that's actually loading. A little green flash is a cache hit. The greens should only appear briefly. And then the yellow shows up when the note's playing. So if I'm holding one note down, you can see kind of a flurry of red as it's loading new grains, but then it's mostly a sort of pool of yellow that evolves over time. If I'm just playing really briefly though, you can see the spray of red as it's trying to load grains. A couple of cache hits, but then it only actually ends up playing a couple of them. Okay, maybe it's a good time to add this next piece of UI that's missing. This blank spot is for a waveform display. This load indicator is actually pretty helpful though. It has kind of the same meaning you'd expect from like a Unix system load. I like these samples of old TV commercials, though. I want to fix my slow importer tool so that I can make more of these.
We do have concert information for Yes.
Next, find out how Spider-Man. Next, find out how Spider-Man. We continue now.
Sparky.
Basically lets the synthesizer and the loading thread get more out of sync than they normally would if we're falling behind. was like, why does this need access to the processor, not just the synthesizer? But this general purpose thread pool is actually pretty important for the image generation. I'm going to try not to worry too much about having a UI that's full of timers running at different rates, and just add another one of those.
Let me get the implement here. Presenting a turning point. Presenting a turning point. Presenting a turning point.
Guess I need to flip the sign on that.
Presenting a turning point. Presenting a turning point.
Solve that. In brief, for the brand.
Strength Tylenol. And light Tylenol. With Advil, I don't have to think.
completely. Why not have? We now return to its
It looks straightforward. So I'll have information, plenty of information to draw here for every voice if I want it. I can draw the outline of the window function. I can draw the actual waveform. I know how to scale everything horizontally because I've got the window size parameters. I'm going to want to, this is another place where I've got to aggregate these things that come in very rapidly and figure out which ones go in which frames. So for the map, I had a bunch of these sets that I could update quickly during the audio rendering and then swap once per frame. I mean, I want something broadly similar here, but instead of deduplicating things by grain, how did I manage the index there? So these are both things that are technically per index, but I'm keeping track of them outside the index, so I need to follow along when the index changes. I guess that was easy in map panel because map panel was already tracking index changes. I don't really need to refer to the index. I mostly just want to deduplicate these waves. Like, I expect that normally one voice will visit, it'll call this function a bunch of times per frame. It also might be called by a bunch of different voices, which might be using different grains or sharing grains. And so either I want something like the other class where I have a set of grain numbers and I clear the whole set using some mechanism that's tracking index changes, or I can have like a map that's keyed on the waveform pointer. It's like we're only going to end up here with waves that are actually loaded, and I think we can just use the pointer to that wave as a hash key. There's even actually a benefit to keeping the wave panel kind of index agnostic. So when you change, like if I'm imagining that I might actually want you to be able to switch between instruments pretty quickly with this, or between data files with this instrument, since it seems like that's actually in the cards, like it does that fine when you just do it manually in the UI. So I might actually want to connect it to an automatable parameter so that you can just trigger data file changes in the middle of a track if you want. And when you do that, the UI will just at some point flip from displaying the previous index to the new index. But those two indexes will continue to coexist for some time. And I think that the waveform display should just show all the actively playing waves, even if they're from a different index. Which means they might also have different max grain widths. Which I was thinking I could use that as a horizontal scale, but maybe not. Maybe the horizontal scale needs to be stationary. Just from a UI perspective, I'm thinking about how I want to handle horizontal scaling. Like if you switch from a really narrow window to a really, really wide one, what I want that to be displayed, does that mean the graph is rescaling? Does that mean the graph always has room for the really wide one? It's like tempting to divide this into subparts here, kind of like this layout and image renderer, but I don't really see a need for that yet. I think I'm just going to have a smart pointer inside the data structure on the value side of the map. and then a void pointer on the key side. If I actually even care about the voice that's playing it. I guess I sort of want to keep track of the latest play position per voice. There's a question from chat about the difference between smart pointers and regular pointers. I think it's a kind of a unfortunate name almost, because like a smart pointer is really like a whole memory management object, whereas a pointer is just an address. You can use them both to refer to an object, right? But a regular pointer in C or C++ is a pretty low-level object. It's really just the address of something in memory with some type information that only the compiler knows. There's no runtime type info by default. So typically the reason you'd want some additional logic there is to keep track of how long the memory behind that pointer needs to be valid for. If you have a bunch of different pieces of code or different threads or different objects or something that are all sharing a single piece of data that might have kind of a complicated to define lifetime, you might need a dynamic system like a reference count or a garbage collector to figure out when that object is no longer used and it can be deleted. So a smart pointer is just a name for one way that people do that in C++ by making an object that kind of looks like a pointer, but actually does memory bookkeeping internally. So this grain waveform pointer would be called a smart pointer in C++, but it's actually just a class that, like when you make one, you're actually constructing a class. When you assign it with the equals operator, you're using operator equals to actually tell the class to copy itself. So like the compiler doesn't see it as a pointer at all. The compiler just sees it as an object, but you can use it as a reference to some other object by using these overloaded operators. And then it implements this functionality that keeps track of just how many different pointers exist to the object at any given time, so reference count. And then when the last reference is deleted, you can delete the object. That's useful here because we have a bunch of different things that are all potentially referring to the same waveform data, and they might need it for a different amount of time. So the original loader of the waveform data can delete its reference, but the synthesizer might still need to be using that for some time until the voices playing that waveform are actually done. So it gives, like, it's a design pattern more than like a feature or anything, and it's a design pattern that a lot of people use to give you features that are kind of taken for granted in a lot of environments, but in C++ are kind of given to your discretion. In this case, what I want is I want to aggregate some information about these waveforms over time. So I actually want to hold on to a reference to the waveforms I'm using. So this is a smart pointer here because I do actually want to increment the reference count and keep this waveform from being destroyed until I'm done with it. But then I was thinking about using the void pointer as a hash key, and that's just because I want something that I'm not going to directly access, but it's just like an indication of uniqueness. And it's convenient if it's already hashable. So this already knows how to hash void pointers. I could do something pretty much equivalent by using an arbitrary other data type and then writing a hasher function for it. So I'm kind of sorting this first by waveform and then by voice. Whereas when I'm actually doing the synthesis, it's all sorted by voice first and then by waveform. I'm wondering if there's a better ID I can use to identify voices. I might just be wanting to use the pointer to these two. Oh, and there's a question about whether it's similar to the RC reference counts in Rust. Yeah, very, like, exact same idea. You'll find the same kind of thing implemented in many different environments. But yeah, this This particular smart pointer that I'm using is one that Juice has. There's also a couple in the C++ standard library. I'm using mostly using like Juice flavored objects to keep the friction low with their API, but there are a couple places I'm using C++ standard library things specifically instead of the Juice things. Okay, I just wanted to see if that compiled. Oh, that's right. The waveform doesn't actually know its own grain number. I don't think I care about the grain number though. I was gonna maybe... Oh, I think I do. I was gonna try to match the color codes. Right now it's really subtle, but there's like a little bit of color coding happening so that the different grains, you know, they go from like light to dark, but they also have like a hue rotation. And anyway, like it would be interesting if, even though that was subtle, if they matched between the different views. And to calculate that, I need the index and the grain number in that index. Anyway, let's keep this simple and just add a couple of things and we can extend it. That actually might be what I want. This cast is unnecessary, but I kind of just want it for documentation purposes. that. Why is wave info not copyable? Is that just a hash map? Yeah, okay. No subclasses of this. Fine. Standard juice hash map, that's wishful thinking. Oh, do we have to ref count this? So the specific problem I'm having right now is that I need to put an object in this hash table that doesn't want to be copied. But of course, unique pointers can't be copied either. I don't know why I thought that would work. I was hoping there was like another hash type here that was going to be more helpful for this. I might just switch to an STL container for this though. It's like, right, I don't want to have an entire ref count for this just because the container is not doing what I want. Let's try a different container. This is a hash function, not a... I wanted a hash map. Sure thought this was a thing. Reconsidering whether I actually want to have nested hash tables like this even at all. All right, like I haven't really been focusing on performance, but like I feel like I'm about to do something that's going to bite me in the ass really quickly. And you know, you ever get the feeling when you're about to do something that is bad for not only performance, but also doesn't even do what you want, and it's going to be annoying. I feel like this is going nowhere good fast. I'm thinking maybe a single layer hash table. Like, I think hashing by waveform pointer is probably what I want. But then the per voice stuff, like the number of voices. I don't know, I was going to say something about the number of voices per wave being pretty small, but I don't know if that's even true. It does seem like it would be reasonable to have like a limited number of slots per wave for things that I actually want to visualize, though. Okay, maybe let's, for the first pass, simplify this even more and not have any voice info and just have wave info. It's getting skittish about how many levels of interaction I was about to introduce into something so performance critical. This is looking a little better. Just one hash table, and we can just stick whatever we want in here. For now, though, I just want to visualize the waves themselves, and then we can get per wave info overlaid on top of that. Oh, actually, that's correct. I never set that. Oh. Yeah, I think we want to const the little point structure, but not these big objects. Doing anything meaningful with these probably involves taking logs or doing things that are actually mutable. Oh, except the sound actually did need to be const. Does it? If I wanted to do anything with the index, that would involve a non-construct sound, I think. Mm-hmm. I guess that is meaningful. Having a const sound means that I can't request any new things from the index, but I can ask the index for stuff that it's already got. That seems like a compelling argument for making the wave non-const, but the sound and the voice const. Okay. Cool, so for every frame of video we want to render, this just has one copy of each of the waves we want on that frame. That looks good so far. Oh, maybe I don't even need to access the index. The waveform is already in samples. I was thinking we needed to scale things by the max grain width in the index. But the waveforms are pretty self-contained because they have everything we need to completely mix and play the grain. So we've got the window shape and the window size in samples at the final sample rate. I think Tuco's making cute noises. I'm still getting hung up a little bit on the horizontal scaling issue here. Maybe I should figure out how to aggregate the playback positions while I think about horizontal scaling. How would I actually render the waveform anyway? Do I want to use a rect list for this? Actually, Juice has some waveform display classes. I don't know if I'd be able to actually use those in their entirety, but it'd be interesting to see how those do the rendering. Audio thumbnail? Yeah. Yeah, let's see how this works. wonder if we even just use this. It's not a component. Maybe we could just like create one temporarily and use it for rendering. Chico's definitely snoring. This is managing a lot of stuff that we do not need for this project. I think I'm just going to look and see how it renders. I'm assuming either it's a rectangle list or they're crafting a bitmap from the pixels up. Maybe they're rendering vertical lines somehow, but it seems like this 2D framework, like the way that it has for doing something like this quickly is its rectangle list. Oh. It is using a rectangle list. I'm realizing that I might want that add without merging also. Yeah, I don't know. The display that shows all the dots for the grains that are active, those are stored in a rectangle list, which I think it's unioning all the additions with by default. So that might be what I want. It might also just be a performance suck that doesn't actually help with anything. Anyway, they are definitely doing the rectangle list thing here. Maybe there's just one global horizontal scale that changes somehow. We could just use the horizontal scale from the currently loaded index, even though the currently loaded index is not really relevant for the rest of this process. It seems like even if I'm not using this this thumbnail renderer, there's There's kind of a design pattern here though, where I will need to at some point convert the audio thumbnail, like the actual waveform data, into a rectangle list. And that operation is going to be relatively expensive and involve allocating a chunk of memory. So it kind of seems like I want that thing to stick in my cache instead of happening on every frame. So maybe one way to do this is just I stick an optional pointer to an audio thumbnail in my wave info. But can I make an audio thumbnail that's not connected to like a file or a format reader or a cache? This might just be barking up the wrong tree. Like I don't think it's going to be fruitful to just have a giant list of rectangles that I'm constantly churning through for this. These waveforms are going to be loaded and well, maybe I push the caching to a kind of earlier spot, and maybe the background loading thread actually just includes the thumbnail in the cache. Like I said, I've got two different architectures fighting in my head right now. One is that we kind of rally around a waveform representation that uses a rectangle list, and then make those as early as possible. Just stick something basically exactly like this, if not this, in the grain waveform object. So anytime you have a waveform, you also have a quick way to draw it. The alternative is keep the waveform format pretty much as it is and write some relatively fast code that will just take that wave data and convert it to an image that has all the active waves. And so if you think about it from the graphics API's point of view, it's either seeing kind of a giant messy pile of rectangles or a single image, but then we have a different amount of work to do. The thing is though, like, since the operation that we're doing is we're taking a long, like this waveform data is usually going to be wider in terms of samples than the window, so we're shrinking this data. We want to basically avoid processing anything that's not actually going to end up on a pixel. And so we've got to pick some like processing sample rate, which the thumbnailer has as an explicit parameter here, not in the cache, but this samples per thumbnail sample, which just would be an unnecessary step for us here, since I know exactly like that. If we've picked a horizontal scale, then we know where the pixels are going to end up. Like another extreme of this design might be to just actually make an image ahead of time. I don't think that actually helps though. Like an image is never any kind of faster or easier to store than a list of like per pixel column waveform samples. If we're making an image in this wave panel, I mean, there are some ways in Juice to just get a pointer to access the raw image data pretty quickly. I mean, that's what I'm doing to do the map image. Depending on the graphics API that this is interacting with, I'm a little worried about kind of like thrashing between video memory and system memory. If we're on a system where the UI has hardware acceleration, which is, I think, macOS and Windows by default, but not Linux by default in Juice, then, like, so far I'm not actually trying to access the Windows backing image as pixels. I'm just kind of infrequently making pre-rendered images and then compositing them onto the screen quickly. I actually want to start accessing the contents of the window every frame. That's the kind of thing that might slow down a hardware accelerated GUI backend. So that would be one argument for sticking with rectangle lists. A rectangle list is probably going to be the fastest way to draw this. I guess the advantage of having an image, or whatever definition of image, per waveform is that might end up being in graphics memory already. That all really depends on the back end. Like on Linux, on the system that I'm running this on right now, it's all software rendered. Juice actually includes its own 2D rasterizer, which is exciting. Maybe the way to do this is to have kind of low resolution or low vertical resolution pre-rendered images of all the waveforms. Which I guess we make on the background threads. It'd be weird to do that work on the background threads when it's actually only needed for the UI. So you'd like to be able to free up that CPU by closing the UI. Anyway, I think I might need to take a break from this and get a bite to eat and think about this architecture a bit. It's not quite the most satisfying stopping point I would have wanted, but we've got the waveform data, we just need to actually visualize it. There's a request for some context. This is a granular synth that I'm working on. Really specifically, I was trying to make the infrastructure necessary for the UI thing that goes right here. I I know that doesn't say much, but I was going to have it display all the currently playing waveforms and the positions in those waveforms. Whereas this thing up here is more like a map of the available waves and which ones are being currently used. Lost my connection.
And you'll enjoy the
Wait, do it now.
Downfall and destruction. Downfall and destruction.
Often work in one dose. Oh, it's even more holiday. New Neo Cinephrine.
Hello, Tic Tac. With the metal master.
Perfect control.
Coming from the metal.
Coming
This one's a bunch of old TV commercials. I've also been playing with Bob Ross voice, or Bob Ross episodes.
To rehabilitating injury.
And as I say, I have just little X's. Don't just try to copy.
A
Don't need a whole bunch.
Some of these have some audio quality problems. Like some of the episodes I put into this had some crackles, and that's coming through.
Many years, and that's my partner. He's right in there. He's right in there. And for blue. My little squirrel pea pod to live. Like little things that I'm going to use some magic squirrels and little trees to do this thing. Come back to do this shows my little things that some magic things that come back to do this things that the little squirrel like that. Very important here and there. I'm gonna go right here and there. Bit of the dark, and from over through that big brush, same color. Permanent red was 10 years ago. Clean through 2 inches. Tiny individual. Individual. And these are your trees. So they can be clean off the canvas right there. And here and there. I'm really good at doing load a lot of paint in there so you don't.
I'm by no means a bad artist. I'm a very good artist. I'm really good at doing
Just take the knife in here and there. Have to just extremely firm, serious progressives. We can do some that are a little firm. This is too thick. A little bit of. I just want a little bit of blue. Show a few little leaves here and there. And letters and sliders and leaves in the center.
Yeah, I could play with this for a while. I should get some lunch and then maybe make it less bad. But yeah, thanks for hanging out. I will try to keep doing these streams pretty regularly. Seems like Tuco's been pretty into them too. Stretch. Alright, I will see you all next time. Happy hacking, folks, and have a good Wednesday or whatever day it is for you.